All right, now we have integration by parts case 2, where we have a product of an exponential function and a trig function. Oh, yeah. And here we don't have any algebraic term. So these are exponential and trig. Now, guess what? When you have an exponential and trig function, you say, what do I make my u? Because I know I've seen that these are two different functions. So obviously it's integration by parts. Now that means, okay, I know my formula would be, my by parts formula would therefore be equal to, it would be something like this. The integration of u dv is equal to uv minus the integration of v du. Okay, sorry for the writing so untidy. Okay, so it's v du, right? And now you say, what do I make my u and what do I make my dv? Well, in this case, it doesn't matter. It doesn't matter what you're going to make your u. It doesn't matter what you're going to make your v if you have a product of a trig and an exponential function. That's good news, right? Yeah, it doesn't matter. It doesn't matter. So here, let's just make our u be the exponential function which comes first, right? Although it doesn't matter which one you make. So you'd say let u be equal to e to the ax. Now du dx, remember you have to know how to differentiate and integrate all these types of functions for you to be good at by parts. This would be e to the ax, right? And then that means my du would be ae to the ax dx. Now I can find my dv. My dv would be equal to cos bx. And that means my v would be the integral of cos bx with respect to x. And what is that integral? So v would therefore be equal to the integral. What do I differentiate to get cos bx? I differentiate sine bx. But remember, when you integrate, it's sine bx first, then you divide by the derivative, because you're integrating. You divide by the derivative of bx, which is just b. So that is my v. So therefore, I know that the integral of e to the ax cos bx with respect to x is going to be, I need this to be able to refer back. It's uv. Uv. What is my u? Is e to the ax, sorry. And then what is my v? My v is sine bx over b. Okay? And then minus the integral of, what is my b? It's still the same. Sine bx over b multiplying du. What is my du? It's ae to the ax. Dx. Okay? So the dx. Right? So this is my pi. So, oh, wonderful. So what are we going to have now? We would say the integral of, if you don't want to keep writing this, well, it's up to you. But you can just write it if you can. The integral of e to the ax cos bx would, with respect to x, would therefore be equal to, this b I can bring it to the front. It would be 1 over b e to the ax sine bx, right? And then I can take out the constants. Minus, what are the constants? B dividing a multiplying. So it's minus a over b integral of let's write it, e to the ax. This x is not down. Okay, it's a power, e to the ax. So here, minus integral of e to the ax sine bx with respect to x. So I've kind of like written this first. The a and the b are just constants, so I've taken them out. It becomes a over b. All right, now I see I have a by parts again here because I have e to the ax sine bx. These are two different types of functions. So I can first find it separately. I can say integral of e to the ax sine bx, okay? I would then say, with respect to x, of course, I would say let u be equal to e to the ax. Again, that means my du dx will be equal to ae to the ax, and my du would be equal to ae to the ax dx. And therefore, I would say let my dv, remember the by parts says the integral of u dv is equal to uv minus the integral of v minus the integral of v du, right? So what is my dv? My dv is sine bx, and what is my v? Is the integral of sine bx with respect to x. that would mean v is equal to, if I integrate sine bx, I get negative cos bx, and then I have to divide by b. Now, so you see why it's important. It's very important for you to be very good at this. So now I can say that means the integral of e to the ax sine bx, okay? Here I'm just solving for this term. It's not actually what I'm looking for. Sine bx is therefore equal to uv, what is u? Is e to the ax times v, what is v? Negative cos bx over b, and then minus integral of v, what is v? Is negative cos bx over b, du, what is du? Is a e to the ax dx. So, of course, now we know that the integral of e to the ax sine bx would therefore be equal to, this negative can come in front, so it will be negative 1 over b, okay? Here, it's minus this negative, minus 1 over b, multiplying e to the ax cos bx. Then this negative comes out, it becomes plus. A is a constant, b is divided, so we take them out. A over b, the integral of, we can start with e to the ax, this one, then we write the cos bx with respect to x. Okay? That's what this is. And if you see something, this is e to the ax cos bx with respect to x, and which is the same as what we are actually looking for. Wow, yeah, that's it. So if I write it again now, I'll be saying the integral of e to the ax cos bx would be equal to, I now write what I had left behind here, which is this one, right? 1 over b e to the ax sine bx, so it's 1 over b e to the ax sine bx minus a over b. What is a over b multiplying e to the a sine bx with respect to x, which is what we just found here, e to the ax, right? So it would be minus a over b multiplying what? Multiplying negative 1 over b e to the ax cos bx plus a over b integral of e to the ax cos bx with respect to x. Wow. Yes, so if I then, this always being multiplied, so I would say the integral of e to the ax cos bx is equal to 1 over b e to the ax sine bx minus, this is minus minus, this is another negative, so it becomes a plus. So plus a times 1, when we multiply fractions, the top multiplies, the bottom multiplies. So a times 1 is a, over b times b is b squared. And this would be e to the ax cos bx. Then negative a over b multiplies this positive, so it becomes negative. Because negative times positive, the signs are not the same, your answer is always negative. A times a is a squared over b times b is b squared. Then the integral of e to the ax cos bx dx with respect to x. Wow. Yeah, so now how do I find my final solution? When you see yourself having gotten the form that looks like the original expression, then you've done half of the job. So you take that, whatever term it is that has that guy, to the other side where here it is. So here we would have the integral of e to the ax cos bx. Okay, this, of course, this is the integral with respect to x, so this is dx. So it's with respect to x. This was negative, so it becomes plus a squared over b squared multiplying the integral of e to the ax cos bx with respect to x. And this should be equal to 1 over b e to the e is not in the denominator, it's on its own. So it's 1 over b, then you have e to the ax cos, oh no, this is now sine. We are now writing what is found here. 1 over b e to the ax sine bx plus, we write this one, which is a over b squared e to the ax cos bx. Done. This one we have taken to the other side, so we don't include. Now what do we factor out? We factor out the integral of e to the ax cos bx dx. So it's the integral of e to the ax cos bx with respect to x is factored out. Here we remain with 1 plus here we remain with a squared over b squared. And this is equal to 1 over b e to the ax sine bx plus a over b squared e to the ax, okay, e to the ax cos bx. Okay, so what are we going to do now? Well, we're just going to have same thing. Now we take this thing that's multiplying to the other side, it divides. So dividing, it's like we have this, so it will be now integral of e to the ax cos bx with respect to x is therefore equal to, okay? If I had 1 plus a squared over this is the same as saying if I want to put 1 over b squared, I'll multiply it by b squared, isn't it? And it becomes b squared over b squared. I can remove this whole 1 whole, and I would make this b squared over b squared, isn't it? And when I add two things that have the same denominator, the denominator doesn't add each other, it just remains the same, but the numerator adds. So I can say this is b squared. Here, if I write it now, it's b squared plus a squared all over b squared. Okay? And when it goes to the other side, because it was multiplying here, when it goes to the other side, now divides, or it flips. It's now b squared over b squared plus a squared. And this is multiplying everything. So it's now multiplying 1 over b e to the ax sine bx plus a over b squared e to the ax. Okay, so it's e to the ax. Let me write it properly there. E to the ax cos bx. And this is your solution, but remember at the end to add the constant of integration c. Okay, so here we've added the constant of integration, and this is what it should look like. Okay, if you want to factor out e to the ax, yeah, it's still fine, all right? If you want to factor out e to the ax, you'd still have, and you can be able to solve. So this is your solution, and that's how you get to it, all right? Yes.